if someone came up to us and said, hey, what's the benefit of a dynamic routing protocol? And we said, you mean like OSPF? They said, yeah, what's the benefit? Well, one of the major benefits is that once we set up OSPF and the neighbors or the routers start forming adjacencies with each other and they start sharing information, we don't have to manually go in and configure new routes, because there's a new route that shows up somewhere else in the network that'll be advertised through our area, and the routers can figure that out on their own without manual intervention. So in this video, here's what we get to do. I'd like to take a look at two types of LSAs, these link state advertisements. They're type 1 and type 2, explain where we would see them and who generates them. And we're going to leverage this topology again. So we have R1, R2, R3, and R4. They're all connected to the same Ethernet network of 10.12.34. The last octet is their respective router numbers, like .1, .2, .3, .4. And they all have a loopback that matches their router numbers. So R4's loopback would be 4.4.4.4. And as these routers build adjacencies with each other, once there's a full adjacency, there's going to be information that is shared. And the two primary LSAs, the link state advertisements, let me back up and change that color. The two major LSA types that we're going to have in a single area OSPF environment are LSA type 1 and LSA link state advertisements type 2. And now the big question, what's in these advertisements? And let's talk about LSA type 1 first. Every router, did I say every? Yeah. Every router running OSPF is going to generate a link state advertisement type 1. And it basically goes like this. If you and I had an interview with R2, let's just pretend we're talking to R2 and say, hey, R2, how you doing? It might say fine or something cordial. And then we could say, tell us about the networks you're connected to. And R2 says, oh, I'm good at this. I do this all the time. I am connected to this network, the 10.12.34 network. My router ID is 2.2.2.2. I've also got a network connection via this loopback interface to this logical address on this interface. And is there anything else that you'd like to know? Well, that information, that's what an LSA type 1 is. It's an individual router. Think about the number 1. One router talking in the darkness, or however that song goes. So that router is sitting there and it's basically explaining its directly connected links, what interfaces it has, what are the costs, its router ID, and then it's advertising that to the network. So that's an LSA type 1. Every router does it on their own, generates their own LSA to communicate to the rest of the network about what they've got going on. Now, an LSA type 2 is describing broadcast networks that exist. So loopback 0 on each of these devices is not a broadcast network, but this common shared network, 10.12.34, with R1, R2, R3, and R4 all connected to it, that information would be included in an LSA type 2. Think of it as describing a specific network and also identifying which OSPF routers are connected to that. Now, how many different times do you think we would need to learn an LSA2 regarding the 10.12.34 network? I mean, if R1 did the LSA type 2 and R2 created it and R3 created it and R4, we'd have a lot of redundant information. I mean, we really only need to know, yep, there's network 10.12.34 and we have routers 1, 2, 3, and 4 connected to it. So instead of having every router create LSA type 2s talking about some shared network, the LSA type 2s are only generated by the router acting as the designated router. So that's it for LSA type 1 and type 2. An LSA type 1 is generated by every router regarding its directly connected interfaces and links and their costs. And a designated router is going to take responsibility for taking the network segment where it is the designated router and generating an LSA type 2 to describe the network and which routers are directly connected to that shared network. Ta-da! Now, you might ask the question, well, Keith, I've seen other types of LSAs, LSA types 3 and 4 and 5 and 7 and so forth. What about those? Those are important on a different day. So if we have larger networks with multiple areas, only then do we start to work with and deal with additional LSA types. So we can save all those discussions on anything above LSA 1 and 2 for another day. And to help reinforce the concept of a type 1 or a type 2 LSA, I have a little protocol capture here that's just kind of giving an overview of a couple of them. So here's type 1 on the left and type 2. Oh my gosh, I can't spell. TYPE2. So here's type 1 on the left and type 2 on the right. Here's what the takeaway is. Type 1s are generated by each and every router. It's going to identify in that LSA the router that generated this LSA and its directly connected networks that it's connected to. So that's done by each and every router. And then for common network segments that are broadcast-based, like Ethernet, where there's a designated router, the designated router will take the responsibility for generating the LSA type 2s, which is referred to as a network LSA. So this includes the advertising router. It also identifies the network and the mask. It's also identifying the attached routers based on their router ID that are all attached to that network. It's these two LSAs, type 1 about each and every router, and type 2 LSAs, which describe networks and who's connected to those networks, that are the building blocks for single area OSPF. And these LSAs, as they're propagated through the network, they get put into an LSDB. That's a link state database. And with all the information about who's connected where and all their link costs, every router can make their own decision about how to forward a packet in the direction of a given network using the shortest path first. So in this video, we've addressed a few specific things. Number one, for LSAs, link state advertisements, we have two general categories that we're concerned with single area OSPF. One is the LSA type 1, which is generated by the router. Just think of it like the router saying, yeah, I've got this network and that network, and here's their costs, and boom, I'm going to package that in an LSA type 1 and hand it off and pass it around the network. Fantastic. That's router by router, a router LSA. And then for broadcast networks, there's going to be a DR, a designated router, and it will take the responsibility of generating an LSA type 2, which describes that network and also identify all the other OSPF routers that are connected to it. And then the DR can propagate that message across the network as well. So the goal is all the routers learn all the information about all the networks, and then they can make their best, shortest path decisions on how to forward IP packets. So I'm glad we had this time together in this video, and I'll see you in the very next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.